Good afternoon, everybody. I am Mahinder Kumar, Senior Lecturer in Civil Engineering from Government Polytechnic College, Batala. Today I shall be discussing with you on the very important topic of curves from the subject of surveying 2 of 4th semester Civil Engineering. So, curves are irregular bends provided in the lines of communications like roads, railways and canals. You understand all these things of communication, just like curves are regular bands provided in the lines of communications, for example roads, railways and canal, etc. For what? That is, we provide curves to bring about gradual change in direction for these lines of communication, just like roads, railways and canals, and these curves are provided to bring about gradual change in direction. So, curves, they enable the vehicle when they are provided on these lines of communications, they enable the vehicle to pass from one path on to another. When the two paths meet at an angle, they are also used in the vertical plane also at all changes of grades to avoid the abrupt change of grades at the apex. That is, in the hilly areas, curves are also provided in the vertical planes to provide changes of grade to avoid the abrupt change of grade at the apex of the hill. So, curves are of two types, one is horizontal curve and another is vertical curves. So, what is horizontal curves? Curves provided in the horizontal plane to have the gradual change in direction. These curves are called as horizontal curves. That is, when we provide gradual change in direction of the lines of communication, then these curves are known as horizontal curves. And similarly, when curves are provided in the vertical plane to obtain the gradual change in grade, that is gradual change in gradient or slope, they are called as vertical curves. So, curves are basically of two types, one is horizontal and another is vertical. So, curves may be circular or parabolic, that is, curves can be circular or parabolic. Curves are generally arcs of parabolas. Curves are laid out on the ground along the center line of the work. That is, curves are laid out on the ground along the center line of the work. So, what is the need of providing curves? Why we provide curves on the lines of communication? So, curves are needed on highways, railways and canals. For what? For bringing about gradual change of direction of motion, that is, when any vehicle is moving on the lines of communications. So, curves are needed or required on these highways, railways or canals for bringing about gradual change of direction of motion of the vehicle. They are provided for following reasons also. First is to bring about gradual change in direction of motion of the vehicle, and secondly to bring about gradual change in grade and for good visibility, as in the case of hilly areas. Third one is to alert the driver so that he may not fall asleep. So, if a road is straight one, that is, there is no turns on either on left side or on the right side. So, there are chances that driver may fall asleep. So, to alert the driver so that the driver may not fall asleep, curves are generally provided. To lay out canal alignment, that is, for the slope of the canal canals and we lay out. So, then curves are also provided for layout of the canal alignment. And fifth is to control erosion of canal banks by the thrust of flowing water in a canal. So, if the curves are very sharp, so there are chances of erosion of canal banks by the fast moving water thrust of the fast moving water. So, to avoid that erosion of canal banks, curves are generally provided in the canal to control erosion of the canal banks by the thrust of the flowing water in the canal. So, these are a few reasons why the curves are provided. So, next one is how we classify the curves. Classification of circular curves. So, circular curves are classified as following 4 ways. Number 1 is simple curves or simple circular curves. Second is compound curves. Third is serpentine curves or reverse curve, it is also called as reverse curve. Fourth is deviation curves. So, these are 4 type of curves which come under the classification of simple circular curves, and we will study one by one of the following as we have just discussed 4 types of curves, we will study one by one. So, first is simple circular curve or simple curve. What is that? A simple curve consists of a single arc of a circle connecting 2 straights. So, you will just study what are the straights, just like AB and BC, they are called as straights. So, when these straights are connected by a single arc, that is there is only one arc, it is called as simple circular curve or simply simple curve. It has radius of the same magnitude throughout as is being shown on your meter screen. A simple circular curve has got same radius of the curve as is being shown on the figure. So, simple curve consists of a single arc of circle connecting 2 straights and it has got radius of the same magnitude throughout. Next is a compound curve. So, as is being shown on your meter screen, a compound curve consists of 2 or more simple curves having different radii, that is it has got more than one radius. So, a simple compound curve consists of 2 or more simple curves having different radii, it has got different radius bending in the same direction, that is they bend on the same direction and lying on the same side of the common tangent. So, as is being shown on your meter screen, a compound curve consists of 2 or more simple curves having different radii bending in the same direction and lying on the same side of the common tangent, that is Mn is common tangent, their centers lie on the same side of the curve, that is radius 1 and radius 2 has got center on the same side of the common tangent Mn, as is being shown on your meter screen. It has got centers which lie on the same side of the curve. So, this is compound curve. So, third one is a reverse curve or a serpentine curve. So, as is shown on your meter screen, a serpentine curve just like a snake, the movement of a snake. So, it is so called as serpentine curve and it is also called as serpentine curve. A reverse or serpentine curve is made up of 2 arcs, that is it is made up of 2 arcs having equal or different radii, that it can have equal radius or the radius may not be equal or different radii, it can have different radius also bending in opposite direction, that is both the curves bend on the opposite direction of the common tangent at their junction. That is, when these curves meet at a junction, it may have different radii and bending in the opposite direction. So, I once again repeat, a reverse or serpentine curve is made up of two arcs having equal or different radii bending in opposite direction with a common tangent at their junction. Their centers lie on the opposite sides of the curve as is shown on your meter screen. O1 center is on the lower side and O2 center of the curve is on the upper side. So, their centers lie on the opposite sides of the curve. Reverse curves are used where they are used when these straights are approximately parallel or intersected at a very small angle. That is, reverse curves are used generally when the straights AB and BC are parallel or intersect at a very small angle. So, next is they are commonly used, these serpentine or reverse curve where they are used, they are commonly used in railway sidings and sometimes on railway tracks and roads meant for low speed, that is where speed of the vehicle is very low, there the serpentine or reverse curve is generally used. They should be avoided, that is they should not be laid as far as possible on the main lines. Serpentine curves or reverse curves are not allowed, or they should be avoided as far as possible on the main lines and highways where speeds are necessarily high. So, these are the figure of reverse or serpentine curve as is being shown on your meter screen. So, these are four types of curves and the fourth one is deviation curve. So, as is shown on your meter screen, a deviation curve is simply a combination of two reverse curves. So, as is shown, please see on your meter screen, this is the combination of different types of curves. So, deviation curve is simply a combination of two reverse curves. It is used when it becomes necessary to deviate from a given straight path, just like an obstruction comes in between the path of a road or a railway, then these curves are provided. So, it is used when it becomes necessary to deviate from a given straight path in order to avoid the intersecting obstructions such as a bend of a river, a building, etc. So, this is the fourth type of curve which is called as deviation, that is we have to deviate from our path. So, namely the curve is also named as deviation curve. So, you see on your meter screen simple circular curve. So, various parts of simple circular curves are being shown on your meter screen. I request you to please see on your meter screen what are various parts of the curves, how they are named. So, I will show you one by one. Number one is the two straight lines A B and B C as it is shown on your meter screen. So, A B and B C, these are called as as straights or tangents to the curve and they are connected by the curve. So, these two straights lines A B and B C which are connected by the curve and are called the tangents and straights to the curve. A B and B C, they are generally known as tangents or straights to the curve. So, second part is the point of intersection of the two straights, that is point B, where these two straights meet A B and B C, they meet at point B. This is called as point of intersection point, or it is also called as the vertex. When the curve deflects to the right side of the progress of survey, that is when we are moving towards from A to B, and when the curve moves to the, it deflects to the right side of the path, it is called as a right handed curve, and when it deflects to the left, it is called as left handed curve. The lines AB and BC are tangents to the curve. These are, I have just said you, AB and BC, they are tangents to the curve. AB, the line AB, it is called as first tangent or the rear tangent, and BC is called as line BC, it is called as second tangent or the forward tangent. The points T1 where the curve starts and the point T2 where the curve ends, they are called as the points T1 and T2 at which the curve touches the tangents are called tangent points. T1 and T2, they are called as tangent points. The beginning of the curve, that is where curve starts, T1 is called as tangent curve point, and end of the curve where the curve ends, it is called as curve tangent point. So, T1 and T2 both are tangent points. The angle between the line AB and BC, angle between the lines AB and BC, angle ABC, it is called as angle of intersection I. The angle by which the forward tangent BC deflects from the rear tangent, angle phi, it is called as deflection angle or simply phi. The distance from the point of intersection point B to the tangent point T1 or T2, BT1 or BT2 is called as tangent length. Distance B to T1 or B to T2, BT1 or BT2, they are called as tangent length. The line joining two tangent points, that is the line which joins point T1 to T2, it is called as long chord. Distance between tangent point T1 and T2 is called as long chord. This black line on your meter screen shows the long chord. The arc T1F T2, this is the curved path T1F T2 is called as length of curve. The midpoint F, please see on your meter screen, the midpoint F of the arc T1F T2 is called as the summit or apex of the curve. The distance from the point of intersection B to the apex of curve F, distance BF, is called as apex distance. The distance between the apex of the curve and the midpoint of the long chord EF, this distance is called as worst sine of the curve. The angle subtended at the center of the curve, this angle T1F T2, this arc, the angle which this arc makes at the center of the curve is called as deflection angle phi. Angle of, so these are the some parts of this curve I have just shown you. Now we come to elements of a simple circular curve. Elements of a simple circular curve. First is angle of intersection plus deflection angle, it is generally 180 degree, that is I plus phi is equal to 180 degree. Similarly, angle TO T2, it is 180 degree minus I angle of intersection, which comes out to be deflection angle, that is the central angle is always equal to deflection angle. Tangent length BT1 is equal to BT2 is equal to R tan phi by 2. Length of long chord is given by the formula 2R sin phi by 2. Length of curve is given by the formula pi R phi 180 degree, where R is the radius of the curve, and the apex distance BF is equal to R secant theta secant phi by 2. So, this is equal to the formula R secant phi by 2 minus R, and finally, it is equal to R over sin phi by 2. So, now we come to a point what is called as designation of curve, that is how we name the curve how we name any curve. So, which is called as designation of the curve. So, a curve may be designated either by radius or by the angle subtended at the center by a chord of particular length. So, this length in India, a curve is designated by the angle, that is, this is very important. In India, a curve is designated generally by the angle in degrees subtended at the center by a chord of 30 meters, that is 100 feet length. This angle is called as degree of curve. So, in India, we designate the curve by degree of curve. So, degree of the curve indicates the sharpness of the curve, that is how sharp a curve is, it is shown by the degree of the curve. In English practice, that is in English countries, a curve is defined by the radius of the curve in terms of chains. You have studied chains in last semester, such as a 6 chain curve means a curve having radius equal to 6 full chains and a chain being 30 meters unless or otherwise specified. So, in America, Canada, India and some other countries, a curve is generally designated by the degree of the curve. For example, a 4-degree curve means a curve having angle of 90 degrees at the center subtended by a chord of 30 meter length unless otherwise specified. So, this is how we designate the curve. So, what is the relation between the radius of the curve and degree of the curve? Now, you see on your meter screen, radius is shown, degree of the curve is also shown, length of long chord is shown and an arc is shown. So, the relation between the radius and the degree of the curve may be determined by as follows. So, let r is equal to radius of the curve in meters, d is equal to degree of the curve, m n, distance m to n is the chord which is 30 meter long and p is the midpoint of the chord. So, in triangle OMP, OM is equal to r, this OM which is equal to radius of the curve is equal to r, MP is equal to half MN is equal to 15 meter. So, in angle MOP is equal to d by 2, this degree divided by 2. So, then sin d by 2 is equal to 15 by r. So, sin d by 2 is equal to 15 by sin d by 2, this is exact relation. So, when d is very small, sin d2 may be assured approximately equal to d by 2 in radians. So, therefore, we derive a formula r is equal to 1719 by d, 1719 by d. This is approximate relation. Exact relation is r is equal to 15 by sin d by 2. This is called as exact relation between r and d, and approximate relation r is equal to 1719 by d. This is called as approximate relation. So, this relation holds good up to 5-degree curve. For higher degree of curves, the exact relation which is r is equal to 15 by sin d by 2 should be used. So, this is the relation between radius of the curve and degree of the curve. So, there are two types of method of curve arranging, that is how we arrange the curve actually in the field. So, the curve may be set out or ranged out in the field by linear methods where chain and tape is used. Second is by angular or instrumental method where a theodolite with or without a chain is used. So, before setting out a curve by any method, the exact position of the tangents point between which the curve lies must be determined or calculated. So, following procedure is adopted. So, what is the procedure? After fixing the direction of the straights, produce them to meet in point B. So, set the theodolite at an intersection of point B and measure the angle of intersection. Then find the deflection angle phi by the relation phi is equal to 180 degree minus I. I is intersection angle. So, we have got either of the two values, we can calculate the second one. So, calculate the tangent length from the following equation. Formula we have with us, tangent length is given by the relation r tan phi by 2. So, we know r, we know phi. So, we can calculate the tangent length. Fourth step is measure the tangent length BT1 backward along the rear tangent B to A from the intersection point B, thus locating point T1 on the curve. Similarly, locate the position T2 by measuring the same distance forward along the forward tangent BC from B. After locating the position of the tangents point T1 and T2, their changes may be determined. The changes of T1 is obtained by this subtracting the tangent length from the known change of the intersection point. That is, we have change of the point B, and we can calculate the change of T1 by subtracting the tangent length from it, and the change of T2 is found by adding the length of curve to the change of T1. Then the pegs are fixed at equal interval on the curve. The interval between pegs is usually 30 meter or one chain length, whichever may be. So, thus this distance should be actually be measured along the arc, but in practice it is measured along the chord, as the difference between the chord and the corresponding arc is small, and hence it is negligible. In order that this difference is always small and negligible, the length of the chord should not be more than 1/20th of the radius of the curve. So, this is very important point. The length of the chord should not be more than 1/20th of the radius of the curve. The curve is then obtained by joining all these pegs. The distances along the center line of the curve are continuously measured from the point of beginning of the line up to the end. That is, the pegs along the center line of the work should be at equal interval from the beginning of line up to the end. There should be no break in the regularity of the spacing in passing from a tangent to a curve or from a curve to the tangent. For this reason, the first peg on the curve is fixed at such a distance from the first tangent point T1 that its change becomes the whole number of chains, that is the whole number of peg interval. The length of the first subchord is thus less than the peg interval, and it is called a subchord. Similarly, there will be a subchord at the end of the curve. Thus, a curve usually consists of two subchords and a number of full chords. So, we now have an example from which you will understand what we have up till discussed. A simple circular curve is to have a radius of 573 meter. The tangents intersect at 1060 meter. This is the chainage, and the angle of intersection I is 120 degree. Find the tangent distance, chainage of the beginning and the end of the curve, length of the long chord, degree of the curve, number of full and subchord. So, if we see the figure 11, the deflection angle is equal to 180 degree minus 120 degree. Radius of curve is equal to 573 meter. So, this is the figure. If you see this figure, we have got the intersection point chainage of T1 and chainage of T2. How we have calculated? Radius is equal to 573 meters. So, this is all shown on the monitor screen. Length is equal to 600 meter. So, we know the tangent length is formula r tan phi by 2, and we calculate it as 330.85 meter. Similarly, length of curve is given by the formula pi r phi by 180 degree. We know pi, r and phi. So, we calculate it as 600 meter. So, this is very important how we calculate change of first tangent point, change of the intersection point minus tangent length, and this comes out to be 729.15 meters. The length of long chord is given by the formula 2 r sin phi by 2. So, we know r, we know phi, and it comes out to be 573 meter, and we know the relation between degree and radius of the curve. R is equal to 1719 by d, which is the exact relation. So, 3 degree comes out to be the degree of the curve. So, What is more important in this numerical is how we find out the full length of card. So, we assume peg interval as 30 meter, chain age of T1 is equal to be divided by 30, that comes out to be chain length. So, 24 full chain length of 30 meter plus 9.15 meter, this is the first sub card. The length of first sub card comes out to be 20.85 meter to make it a whole number. So, 45 there will be full chain length of 30 meter.